Here is an interesting connection between a right-angled triangle and the area of circle. Let's verify. The area of a circle whose diameter is the hypotenuse of a right-angled triangle equals the sum of the areas of the circles built on the other two sides. This is the very familiar Pythagoras theorem applied in a right angle triangle, whatever we have studied till now. Triangle ABC is right angled here with 5 units as hypotenuse and 4 units as height and 3 units as base. The statement of the Pythagoras theorem very familiar with the area of the square. The square of the hypotenuse is equal to sum of the square of the other two sides. The square of the hypotenuse refers to the area on the hypotenuse. Similarly, the sum of the squares on the other two sides. So here 3 into 3, 9 is the unit, square units for the square on the base, and 16 square units as the square on the height, and 25 square units as the square on the hypotenuse. Let's start from this and we will arrive at the area of the circle with the hypotenuse as the diameter will be the sum of the other two circles having the other two sides as the diameter. Observe, this is the circle with hypotenuse as the diameter. So it is already I have drawn the circle with the hypotenuse as the diameter, and one more with the base as the diameter. It fits here, and one more with the height as the diameter. We are going to check if this is true. You can see this. This one is the diameter, and here the base also fits. So let's verify by theoretical approach. So we have studied that c square is equal to a square plus b square. So being this is an equation, I can multiply both sides by pi by 4. So pi by 4 into c square is equal to pi by 4 into a square plus b square. So this can be rewritten as pi by 4 c square is equal to pi by 4 a square plus pi by 4 b square. Pi into c by 2 whole square is equal to pi into a by 2 whole square plus pi into b by 2 whole square. Pi into c by 2 whole square is equal to pi into a by 2 whole square plus pi into b by 2 whole square. What is this pi into c by 2 whole square? C is this, the hypotenuse, and c by 2 is its radius. So we have drawn the circle on the hypotenuse as the diameter and with the c by 2 as radius. C by 2 is the radius. Is it not pi into c by 2 whole square, the area of this circle, purple circle, whatever we have drawn? So it is this circle, biggest circle. Area is pi into c by 2 whole square. Similarly, pi into a by 2 whole square is a by 2 is 2 units. The radius of BC, radius of the medium sized circle, which is the base BC, half of that. So that is the radius. So its this circle's area is pi into a by 2 whole square. Pi into b by 2 whole square is this red circle, whatever is drawn. Its area. We have seen that 3 units is the diameter and 1.5 is its radius, and the circle which is drawn with this as height as diameter, its area is pi into b by 2 whole square. So this is nothing but area of biggest circle is equal to sum of other two circle areas. This is very clearly letting us the connection between the right angled triangle and the area of circles. Isn't it really beautiful? We can verify the same using this area of this. This is the area of the biggest circle. See, in case I feel some grains in that. Area refers to the surface it occupies. So this is the this occupies the bigger circle. Now if I distribute the same into two circles, it will exactly cover the two circles areas. This becomes the practical verification. It exactly occupies the equal surface. So this indicates that these two areas together count to total to the area of the bigger circle.